A graphing calculator is recommended. Draw the graphs of f, g, and f plus g on a common screen to illustrate graphical addition. So we are to add the two functions, f of x equals the fourth root of 2 minus x, and g of x equal to the square root of 1 minus x squared over 9, and then choose which of the set of graphs is correct. So we will begin by graphing the function f of x equals 2 minus x raised to the 1/4. It is convenient to express this in this way on a graphing calculator. We were given the function f of x equals the fourth root of 2 minus x. But recall that a rational exponent is the same as the index of a radical. Now, one thing that we realize here is that this is an even root. So the expression 2 minus x must be greater than or equal to 0, so that when we take the fourth root of that value, we get a real number back. Solving for x here, we see that x would have to be less than or equal to 2. So it makes sense that our graph extends up to positive 2 on the x-axis and not beyond. Also, we notice that f of 2 is equal to 0. Now let's add to that the square root of 1 minus x squared over 9. We see that that graph extends from negative 3 to positive 3 on the x-axis. And that makes sense because when we square the value negative 3 or positive 3, we wind up with 9. And 9 over 9 would be 1. And what is underneath this radical has to be positive. So x squared over 9 can't exceed 1, so x squared can't exceed 3, nor can it be less than negative 3. Now the fact that f of negative 3 is 0 is significant here. So now we'll add to this the sum of the two functions, which is shown in green. Recall that when we were analyzing our graphs earlier, we noticed that the domain of f did not exceed 2. X was less than or equal to 2. We also noted that the domain of g only extended from minus 3 up to positive 3. The sum of the two functions can only exist where the original functions exist. So that means then that the smallest value of x that can be used in the sum of these two functions would be negative 3. The largest would be positive 2, so the domain for the sum of the two functions would be from negative 3 to 2. We also noted that f and g were positive over their entire domain. So since they're positive, when we add two positive numbers together, we wind up with a value that exceeds the original numbers. So that means that f plus g of x would be larger than f of x, and it would also be larger than g of x. So it's not a surprise then that the entire function f plus g lies above both of the functions f of x and g of x. Since g of negative 3 is equal to 0, then it makes sense that f of negative 3 plus g of negative 3, which would be f of negative 3 plus 0, would just be equal to f of negative 3. So the two functions f of x plus g of x and f of x would be equal when x is negative 3. So they should intersect when x is negative 3. We also noted that f of 2 is equal to 0. So f of 2 plus g of 2 is really just 0 plus g of 2, which would just be equal to g of 2. So it makes sense that the two functions f plus g and g would intersect when x is 2.